स्टार्टिंग ऑफ विद योर टॉपिक नंबर 7A, और जो हमने आज पूरा कवर करना है विच इज प्रोबिंग मैटर। एंड इन द नेक्स्ट टू क्लासेस वी विल बी कवरिंग 7B एंड देन 7C, और आपका पूरा टॉपिक नंबर 7 कंप्लीट हो जाएगा। सो व्हाट प्रायर नॉलेज डू यू नीड, वो हमने प्रायर नॉलेज थोड़ा बहुत डिस्कस भी कर लिया था, जिसमें हमने आपको थोड़ा सा मैटर बताया, न्यूक्लियर एटम क्या होता है, उसकी थ्योरीज क्या थी, रेडिएशन टाइप ऑफ, वो सारा कुछ आपकी बेसिक्स हमने क्लियर कर दी थी पिछले लेक्चर के अंदर। विल स्टार्ट ऑफ डायरेक्टली विद व्हाट इज अ न्यूक्लियर एटम, व्हाट इज मेंट बाय न्यूक्लियर नंबर, व्हाट इज अ प्रोटॉन नंबर, एटॉमिक नंबर, ये अल्फा पार्टिकल स्कैटर एक्सपेरिमेंट क्या था जिसने न्यूक्लियर एटम का एक एविडेंस दिया था। यू हैव स्टडीड दिस ऑलरेडी ट्वाइस as well, or a Rutherford scattering experiment is not new for you as well. Describe how understanding of the atomic structure has changed over time as well. Then people have always asked questions about what the materials around us consist of. Obviously, they are made up of atoms. Who proved it? Ki solids, liquids, and gases. Who was the one who actually proved that everything is made up of atoms? Everything consists of atoms. Who was the one who actually approved ki yes, these particles are atom? There was Democritus as well. There was a Dalton theory as well, who suggested the idea of a tiny particle from which everything else is constructed. He proved that there is a basic model of atom. You have to study a basic model of atom, and once you know what's a basic model of atom, you should know that this atom is the one that has made up all of the different types of matter around you. Matter can be in a lot of states, matter can be in a lot of materials as well. So that's where the basic model of one of these atoms was then published by the paper by Dalton in 1803, that it is simply a हार्ड सॉलिड स्फेयर। सबसे पहले डेमोक्रिटस ने कहा था क्या, एक बॉक्स है। इट वो ही वाज द फर्स्ट टू सजेस्ट द एग्जिस्टेंस ऑफ एटम्स। ही ओनली सेड एटम्स एग्जिस्ट। हाउ डज इट एग्जिस्ट, what do they look like? He didn't tell anything. He was the one who just said that atoms exist. How did you know they exist? Because whatever object, materials, matter that you see around yourself, he said this is made up of something, and that something is atoms. Now we have no idea till now that what does atom look like. Then came Dalton model of atom. He found that atoms have different masses and they can be combined to produce compound molecules, and he then gave us an idea of a solid sphere. After that came the Thomson's plum pudding model of the atom, जिसमें obviously both Democritus and Dalton never talked about the charges that exist in an atom. Thomson's plum pudding model of an atom gave us an idea that all right, atoms are actually having a bunch of negative electrons as well that are scattered through a positive dome, which means that these negative electrons are like swimming around a pool of positive ions that could be removed as well, that could be added as well, and that gave rise to the plum pudding model in 1906. This model suggested that the main body of the atom is composed of a positively charged material with electrons randomly scattered through it. This model was successful at explaining the evidence available at that time. And then in 1911 came another model, and this was proposed by Rutherford. कि ठीक है, he agreed that this there are charges, but he also carried out the alpha scattering experiment, from which he saw that most of the alpha particles were passing straight through the atom and only few of them bounced back, which means that all of the mass of the atom was concentrated inside a nucleus. There is a tiny central nucleus present, and the rest of the atom is completely an empty space. This is which was proved by the alpha scattering experiment, that there's a tiny charged nucleus that carries most of the mass of the atom, surrounded at some distance by the electrons, with most of the atom as empty space. Is it clear?
हाँ जी।
Niels Bohr then further refined that more. Niels Bohr ne kaha ki all right, I'll just refine Rutherford a bit. He said that Rutherford thinks that electrons orbit the nucleus. He proved that electrons orbit in different shells, different energy levels. There's not just one shell, there are different fixed energy orbits. All these different shells have different energy levels. He only refined the nuclear model to have the electrons located around the nucleus in fixed orbit, following the theory of quantized energy. Electrons could move from one fixed orbit to another depending on the energy they gained or lost. Apart from these fixed jumps, they were stuck in an orbit, and Bohr's model generated the commonly used idea of atom as being like miniature solar system. This idea is not a perfect model and it is incorrect in many ways as well. But again, models always have their strengths as well, they always have their weaknesses as well. But we always have to choose the model that is the best one. We don't say that this model is like 100% accurate and all, but obviously the one that has the least amount of limitations and the one which is the least, most correct, we can say the best one out of the all, we choose that model as well. Rutherford was the one who did this alpha particle scattering experiment. Giger and Marston, the students of Lord Rutherford at Manchester University, did an experiment. उन्होंने क्या किया that they took a thin gold foil. Now, what is this gold foil? Gold foil is also what? A piece, है ना? It's like a material. This gold foil is what? It's a material, and obviously you know that this material has atoms as well. And they started to fire what? Alpha particles at the gold foil, and they saw. Their expectation was that all of the alpha particles will pass through. Why? Because which model did they have in mind? The plum pudding model. They thought that the atom is a plum pudding model, and they thought that if we keep firing alpha particles at this atom, all the alpha particles will straight pass through. And that happened actually. 99 out of 100 alpha particles used to pass straight through. But there used to be 1 out of 100, which they were like, why is this one bouncing back? ये वाला क्यों वापस आ रहा है? That's where they move from the plum pudding model to the Rutherford nuclear model. That nahi, there is something in between the atom. Atom is not completely a cloud or empty or just having charge. There is something in between the atom because 99% of our alpha particles pass straight through. Why does one of the alpha particles bounce back? Because there is something in between, in the middle of an atom, and this followed the same pattern. Then he also saw one thing. Then when he fired an alpha particle, some of the alpha particles deflected as well. Now what does that tell you? Why did the alpha particle deflect? Can you tell me what's the charge of an alpha particle? Positive, right? तो क्यों डिफ्लेक्ट किया
ऑपोजिट
होगा?
होता है।
डिफ्लेक्ट क्यों हुआ होगा? क्योंकि न्यूक्लियस भी क्या होगा? पॉजिटिव. Otherwise, though, it would have been attracted, right? So there were three observations that comes from the alpha scattering experiment. I'll tell you the first one. The first observation was that most of the alpha scattering experiments passed straight through. That proves that okay, atom is mostly an empty space. Number two, very few of the alpha particles used to bounce back as well, which proved that there is a tiny nucleus that contains all of the mass of the atom. And the third observation was that some alpha particles, when fired, they don't bounce back but they deflect. And the only reason for the deflection can be because they know that alpha is positive. Then why would they have deflected? There is only one possibility that this thing, which is known as a nucleus, is also what? Positive. Only then there could have been a force of repulsion that actually deflected, repelled the alpha molecules. Otherwise, if they would have attracted, then nucleus, though, we would have concluded that nucleus तो negative है. But we concluded that nucleus is positive because that positive caused repulsion and the deflection of alpha particles. Is this clear? And the
हाँ
closer
जी।
the alpha particle went, the more it deflected. The farther the alpha particle was from the nucleus, the less it deflected as well. And hence they repeated this experiment several times, and that's why they changed the whole model of the atom. And finally, this is what the alpha scattering experiment kind of looks like as well. The Rutherford's alpha particle scattering experiment. You can see the first observation is what most of the alpha particles passed straight through. That proves that atom is mostly an empty space. Some of the alpha particles have a deflection as well, which proves that nucleus, because alpha is also positive, the nucleus must also be what? Positive. And the third observation was that all of the mass of the atom is not distributed. It is actually centered. It is actually it is actually concentrated in the middle of an atom in a very tiny mass. And the closer the alpha particle moves closer to the nucleus, we see a deflection at larger angles. Got it? These are the four observations. Any problems in all four observations?
नहीं।
Hmm? Good. All right. So, the ones who only deflected 10 degrees, that meant that alpha particles were passing straight through. There was little or no deviation, which means that most of the atom was an empty space. Some alpha particles deflected through a larger angle, which means that there's a very large concentration of positive charge present in one place, which they called as a nucleus. And a very few alpha particles were the one who literally deflected, bounced back, which means most of the mass of an atom and the large concentration of charge is there in the central nucleus. Then came the discovery of neutron. Chadwick's discovery of neutron was quite interesting as well. Rutherford determined that most of the atom's mass and all of the positive charge were held in between the small nucleus in the center, and the electrons were at the edge of the atom. The difference between the nuclear mass and the known number of protons has caused a problem though. Nuclei were too massive considering number of protons they contained. अब उन्होंने कहा यार nucleus, it's not possible because if you look at the mass of the nucleus and if you look at the mass of the protons, there is no way that the nucleus mass is equal to all of the protons that are present. They then came to know that there must be something other than the protons as well that will be present in the nucleus. And that's where they came to know about the neutrons as well. Because obviously, when they calculated the total mass of protons and total mass of the nucleus, it didn't equate, it wasn't equal. That proves that nucleus is very big. It's not possible that only protons are taking all of the space inside the nucleus. There is a possibility that there is someone else inside the nucleus as well, sharing the same space with protons. Got it?
लेकिन उनको कैसे पता नहीं था वो इलेक्ट्रॉन
अभी
भी हो सकता है क्योंकि अट्रैक्शन नहीं हुई।
एग्जैक्टली
अगर
अट्रैक्शन नहीं
अगर-
हुई ना, हमने ये बिकॉज हमने
हाँ,
अभी वो देखा अल्फा स्कैटरिंग से पता लग गया था दैट द ओनली चार्ज द न्यूक्लियस हैज इज पॉजिटिव। नेगेटिव तो है ही नहीं ना,
नहीं
वरना तो
क्योंकि
फिर
अल्फा को होता +2 में।
एग्जैक्टली अल्फा स्कैटरिंग एक्सपेरिमेंट
लेकिन
में तो फिर अल्फा को अट्रैक्ट हो जाना चाहिए था ना, इफ द न्यूक्लियस
नहीं
हैड
लेकिन
अ
अल्फा का चार्ज होता +2 या +1 +2 होता है नहीं।
+2 होता है लाइक अ हीलियम न्यूक्लियस।
हाँ,
बिल्कुल।
तो फिर अगर वो एक मतलब दो प्रोटॉन से एक इलेक्ट्रॉन तो फिर भी रिपल्शन ही होगी नहीं।
नहीं नहीं, बट
क्योंकि
ओवरऑल आपका फिर वो न्यूक्लियस पर जीरो, फिर तो न्यूक्लियस न्यूट्रल हो जाता। फिर तो न्यूक्लियस ही न्यूट्रल होता,
अच्छा,
फिर तो डिफ्लेक्शन ही ना होती ना। देखो तीन पॉसिबिलिटीज है, या तो डिफ्लेक्शन
एक ही
ना हो,
सारे प्रोटॉन्स।
ठीक है,
हम्म।
तीन पॉसिबिलिटीज करते हैं, सारे इलेक्ट्रॉन्स हैं न्यूक्लियस में, सारे प्रोटॉन्स
हम्म।
हैं, या आप कह रहे हो कि चलो दोनों भी अगर होते हैं, अगर वो कहते हैं कि जो बाकी की जगह है वो इलेक्ट्रॉन्स ने ली हुई है, न्यूक्लियस में प्रोटॉन
हम्म।
अकेला नहीं है, इस केस में ओवरऑल न्यूक्लियस का चार्ज क्या हो जाता? जीरो। ना होती ना फिर डिफ्लेक्शन, फिर
नहीं
डिफ्लेक्शन क्यों
नहीं,
हुई?
लेकिन +2 होता है प्रोटॉन में।
वो ठीक है, वो उसमें इतनी डेप्थ में नहीं कि
अगर दो
+2 होता है
प्रोटॉन्स है
नहीं
एक
है।
इलेक्ट्रॉन
आपके
है तो
पास
फिर वो।
एक अल्फा पार्टिकल अगर जा रहा है, हाउ डू यू नो कि उस
हम्म।
एरिया उस रीजन में दो प्रोटॉन है, एक है, तीन है, चार है, 10 है, 12 है? वी डोंट नो दैट। आई एम सेइंग इफ यू आर सेइंग
अच्छा, वो
दैट
इरेलेवेंट
वो,
है।
ना हाँ,
अच्छा।
फिर तो
अच्छा, ठीक है।
डिफ्लेक्शन ही ना हो। यहाँ पे अगर हम
रिपीट हो
कहें कि
जाएगा, ठीक है।
न्यूक्लियस में सिर्फ इलेक्ट्रॉन्स थे, देन तो अल्फा पार्टिकल आता, अट्रैक्ट, चिपक जाता आके न्यूक्लियस के साथ।
जी जी,
वो
अट्रैक्शन हो
चिपका
जाएगी।
भी नहीं,
और
वो डिफ्लेक्ट हुआ,
ठीक
विच
है।
मीन्स के फिर तो न्यूक्लियस में पॉजिटिव ही है। लेकिन मसला ये आया कि उन्होंने कहा कि प्रोटॉन्स का मास इक्वल हो नहीं रहा न्यूक्लियस से, मतलब कि प्रोटॉन के अलावा भी अंदर कोई है, जिसकी वजह से
हम्म।
न्यूक्लियस का मास प्रोटॉन से भी ज्यादा आ रहा है। अब इसमें तो इट वाज बिकमिंग डिफिकल्ट टू डिटेक्ट एज वेल कि एक अननोन से एक अनचार्ज सी रेडिएशन आ रही है दैट वाज बीइंग डिटेक्टेड बाय द गीगर मुller ट्यूब। तो एक क्यूरियस आया, ही सेड दैट दिस अननोन रेडिएशन इज gamma ray, उसने कहा ये gamma rays है, बट अगेन एज दीज रेज हैव नो मास, दिस वाज अगेंस्ट द रूल्स ऑफ कंजर्वेशन ऑफ मोमेंटम। उसने कहा नहीं, मास तो है इनका, गैमा तो खैर जीरो जीरो होता है ना, गैमा क्या है, गैमा तो जीरो जीरो। उन्होंने कहा नहीं भाई, गैमा नहीं है। वाई? बिकॉज उस चीज का मैस है भाई, उसने न्यूक्लियस में जगह ली हुई है। गैमा तो आप अनलिमिटेड रख दो, वो कभी जगह ही ना ले, गैमा का तो मैस ही नहीं है। देन दे बोला अच्छा गैमा भी नहीं है, फिर क्या है? देन चैडविक ने मोमेंटम ट्रांसफर, मोमेंटम को यूज करना चाहा, बिकॉज मोमेंटम इज द प्रोडक्ट ऑफ मास एंड वेलोसिटी, and he also used the conservation of kinetic energy in colliding these particles as well, and concluded that beryllium radiation was a neutral particle which has a mass of 1% more than that of a proton. And he then published a proposal for the existence of this new particle that is known as a neutron. Beryllium क्या होता है? Beryllium is with the proton number 4, it's in the periodic table, right? और उसने कहा
हम्म।
कि when they collided with the nucleus, न्यूक्लियस में सपोजिटली हमने कहा सिर्फ प्रोटॉन्स होते हैं, ही सॉ दैट इनका सिर्फ एक ज्यादा था, या मीनिंग आप ये कहो कि इफ द मोमेंटम ऑफ बेरिलियम वाज 2, द मोमेंटम ऑफ न्यूक्लियस केम अबाउट टू बी 4। मतलब कि अब उस 4 में से 2 मोमेंटम होगा पी का, लेकिन टू ही
कुछ और
एग्जैक्ट
होगा।
किसी और का है। और वो बिल्कुल प्रोटॉन की तरह ही है, सेम मैस है प्रोटॉन जितना ही, और इसलिए वो सच बात है, प्रोटॉन्स एंड न्यूट्रॉन्स
नहीं,
हैव एग्जैक्टली
लेकिन
द सेम मैस।
उन लेकिन उनको कैसे पता है? हमें तो पता है वो प्रोटॉन का मास 1 होता है और न्यूट्रॉन का भी मास 1 है। लेकिन इधर इस एग्जांपल में तो प्रोटॉन का 2 भी हो सकता है, नहीं?
नहीं, अगेन,
क्यों?
व्हेन दे कैलकुलेटेड फर्स्ट द टोटल मास ऑफ द न्यूक्लियस, वो एग्जैक्टली हाफ
हम्म।
ही आ रहा था फ्रॉम द masses ऑफ the proton, and plus in order for the charge to be equally distributed and the overall charge to be positive, there had to be equal number of protons, but all of those neutrons were actually neutral. Beryllium को समझे, beryllium का proton number is 2, it had a momentum of
हाँ।
2, ठीक है, प्रोटॉन नंबर उसका क्या लिखा है, 4 है, उनका मोमेंटम आ
हम्म।
गया लेट्स से 2, न्यूक्लियस का
ठीक है।
मोमेंटम आ गया 4, एंड ही देन सेड दैट इट वाज एग्जैक्टली लाइक, आप कहो कि न्यूक्लियस का जो मोमेंटम था दैट वाज डबल ऑफ बेरिलियम, विच मीन्स कि अगर इस 4 में से दो मोमेंटम आया है प्रोटॉन की वजह से, देन एग्जैक्टली दो आया है किसी और पार्टिकल की वजह से ही। एंड यू कैन जस्ट रिमेंबर दीज
अच्छा,
टू लाइक
कुछ और
दैट।
है, वो प्रोटॉन नहीं है बेसिकली बस।
प्रोटॉन नहीं है, वो तो बहुत शुरू में ही पता लग गया
ठीक
था।
है, ओके।
एंड देन ही वाज अवॉर्डेड द नोबेल प्राइज। खैर ये वाला क्वेश्चन आपसे पूछा नहीं जाएगा, अल्फा स्कैटरिंग जो हमने ऊपर पढ़ा वो बहुत ज्यादा जरूरी है और वो हर साल आएगा आपके पास। नाउ वी हैव सीन, अब बाकी केमिस्ट्री है आगे, आप ऑलरेडी केमिस्ट्री के स्टूडेंट रह चुके हो, सो दिस इज नथिंग न्यू टू यू। उन स्टूडेंट्स को मसला होता है दैट हैव नॉट एवर स्टडीड केमिस्ट्री एज वेल। So, nucleus contains two types of particles, protons and neutrons. In the nucleus, these particles are together known as nucleons. Number of protons in a nucleus determines which element the atom will be, and the periodic table is a list जो आपको सारे प्रोटॉन नंबर के हिसाब से 118 एलिमेंट्स आपको you are given in the periodic table. We represent proton number by the symbol Z. We represent the total mass or nucleon number as A. And if you want to find the number of neutrons, आप mass में से protons को minus कर सकते हो, तो you will get what? The neutron. For example, radium में कितने neutrons है, 226, minus the number of protons, you will get your answer as 138 neutrons. Got it?
ठीक।
प्लस एक और सवाल आया है किसी के जहन में, उसने कहा कि चलो आप लोगों ने ये बता दिया है दैट द न्यूक्लियस कंटेन्स व्हाट, प्रोटॉन्स 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 हैं, ठीक है, और न्यूट्रॉन्स हैं जिनका चार्ज है ही नहीं। ये सारे प्रोटॉन्स आपस में रिपेल करके न्यूक्लियस को फाड़ क्यों नहीं देते? Why doesn't the
ठीक है, इफेक्ट नहीं
nucleus
कर रहे हैं।
blow up? न्यूट्रॉन्स तो ऐसा तो नहीं है कि न्यूट्रॉन्स
वो
नेगेटिव
इफेक्ट
एनर्जी
तो नहीं
में,
करेगा। हाँ।
एग्जैक्टली वो फट क्यों नहीं
रिपल्शन
जाते?
होगी तब वो एक पॉजिटिव एक नेगेटिव है। तो
एग्जैक्टली,
अगर न्यूट्रल एक है तो।
अगर सारे चार्जेस हैं ही पॉजिटिव न्यूक्लियस में, why is the nucleus not blowing up? देन वहां पे एक फोर्स डिस्कवर हुई दैट देर इज अ मच स्ट्रॉन्गर फोर्स देन इलेक्ट्रोस्टैटिक फोर्स, विच फोर्स इज नोन एज the strong nuclear force that holds all of the positive charges in the protons together. अगर ये nuclear force ना हो, these protons are always repelling each other inside the nucleus. Got it? So there is a strong nuclear force that has held all of these electrons in protons in place. To describe any nucleus, ये मैंने आपको बता दिया, how do you calculate the number of neutrons, mass number minus the
जी जी।
proton number.
एटॉमिक नंबर।
In 1920s, Heisenberg changed the model of the atom which had electrons in orbit like planets in the solar system. His uncertainty principle says that we cannot know the exact position and velocity of anything at any given moment. इसी तरह अगर हम पहले बचपन में किसी को पढ़ाते थे कि ऑर्बिट क्या होता है जहाँ इलेक्ट्रॉन होता है, फिर ये डेफिनेशन अब हम ए लेवल्स में चेंज कर देते हैं। आपको क्या पता कि लेट्स से चलो एक एस ऑर्बिटल है, एस ऑर्बिटल तो स्फेरिकल होता है, अगर एस ऑर्बिटल में एक इलेक्ट्रॉन है तो वी नो कि वो इधर ही है ना, पर ठीक है, अगर वो एक इलेक्ट्रॉन पी ऑर्बिटल में है, ऑर्बिटल भी पी है, और इलेक्ट्रॉन आपके पास एक है, अब आप बताओ आपको कैसे पता कि वो इस वाले में है या इस वाले हिस्से में है? ऑर्बिट तो एक ही है, वी डोंट नो दैट राइट, बिकॉज पी ऑर्बिटल तो एक डंबल शेप का होता है। अब आपको क्या पता कि इलेक्ट्रॉन इस वक्त इधर है या बिलो द प्लेन है? वहां से दे चेंज द डेफिनेशन ऑफ ऑर्बिटल, दे सेड ओके, we won't say कि electron is present in the orbital. We say that if this orbital or a shell is a region or a space where there is a maximum probability of finding an electron. हम ये नहीं कहेंगे electron is there. We won't define shell, we won't define orbital like we used to do. Now we are going to change the definition to what? there is a maximum probability. This is a region or a space where you'll have the maximum chance or maximum probability of finding an electron, and that's
ये
what we call
मैक्सिमम कितनी
probability.
होती है?
क्या चीज?
ये मैक्सिमम कितनी होती है? ये 50%, 90%, 20%, ये कोई?
नथिंग, वी डोंट नो दैट. इट कैन बी 1%, एज इट्स अ प्रोबेबिलिटी ना, 50-50 है ना यहाँ पे तो, कि ऊपर है या नीचे है. ठीक है. एंड
हाँ अच्छा,
इट्स
ठीक
जस्ट
है।
अ मैक्सिमम प्रोबेबिलिटी, वी कैन से
ये वो
इवन
वन
इफ
एस
इट्स
टू
फिफ्टी
टू एस
वन
टू टू पी
परसेंट
सिक्स ये आता है इधर या नहीं?
बिल्कुल है. वो इधर नहीं है, मतलब वैसे आपको बताया कि एस ऑर्बिटल में
अच्छा।
हो, केमिस्ट्री में जैसे आपने पढ़ा था, एक एस ऑर्बिटल में तो पता है स्फेरिकल शेप, इलेक्ट्रॉन इसी में है ना. लेकिन
हाँ जी
अगर
जी।
पी ऑर्बिटल आउटर शेल आ रहा है किसी एलिमेंट को, और उस पी ऑर्बिटल में लेट्स से कोई एग्जांपल कर लेते हैं, बोरॉन है. बोरॉन
हम्म।
5 होता है ना, तो 1s2, 2s2, 2p1.
2p1। हाँ जी।
अब पी ऑर्बिटल में एक ही इलेक्ट्रॉन, आपको अब क्या पता है कि वो ऊपर वाले प्लेन में है इस वक्त फिर रहा है या नीचे वाले में फिर रहा है. यू नेवर नो दैट,
हम्म
उसकी मर्जी इलेक्ट्रॉन की. सो दैट्स व्हाई यू हैव अ मैक्सिमम प्रोबेबिलिटी, इवन इफ इट्स 51%, it is still greater than 49%. It's still maximum. It's still the
हम्म।
maximum most probability that you can have. Got it? Free
ठीक है।
conduction electrons in the metals need a particular amount of energy if they are to escape from the surface of the metal. This energy can be supplied by a beam of photons as well that you previously observed in photoelectric effect as well. What were photons basically? Photons were also packets of energies that carry energy. And when we discovered light as a particle, this is what light as a particle looks like: photons. The electrons can also gain enough energy through heating of the metal, and the release of electrons from the surface of the metal was known as thermionic emission, or what we also call as the photoelectric effect as well. कि आपको याद होगा, when a photon used to strike the surface of the metal, electron used to be emitted from that surface of the metal as well. And if they, when they escape, these electrons are in an electric field and they will be accelerated by the field as well. And the kinetic energy will then depend on the voltage as well, because potential difference क्या है? It is basically the work done per coulomb charge ना. work done भी तो kinetic energy ही है. And I think you already know how to convert from joules to electron volts to joules. So let's say, how fast would an electron be moving if it was accelerated from rest through a potential difference of 2500 volts? Now, again, kinetic energy is equal to EV, electron volts. So you can multiply इलेक्ट्रॉन इंटू द वोल्ट इज इक्वल टू, यूल फाइंड द टोटल एनर्जी. इस एनर्जी को आप कह लो कि दिस इज द काइनेटिक एनर्जी बेसिकली, बिकॉज ऑब्वियसली इफ समथिंग इज एक्सेलरेटेड, जो भी आपने यहाँ एनर्जी निकाली है इलेक्ट्रॉन वोल्ट को यूज करके, वोल्ट दिया हुआ था, आपने एक इलेक्ट्रॉन से मल्टीप्लाई करना है उसको चार्ज से. अब आपके पास के ही पता लग गई है, आपको मास ऑफ इलेक्ट्रॉन भी डाटा बुकलेट में दिया होता है. यू कैन देन इजीली रीअरेंज द इक्वेशन ऑफ हाफ एम वी स्क्वायर, और आप v को सब्जेक्ट बना के यू कैन कैलकुलेट इट. मास ऑफ इलेक्ट्रॉन इज ऑलरेडी गिवन टू यू इन द डेटा बुकलेट. Using thermionic emission to produce electron and applying an electric field to accelerate them, we can actually generate a beam of fast moving electrons known as a cathode ray. And if this beam of electron passes through a further electric or magnetic field, then the force produced on the beam of electron will cause it to deflect. If a fast moving electron hits the screen, it is planted with a specific chemical, और ये वो वाला भी है जिसमें हमने इलेक्ट्रॉन को एज अ वेव कहा था. बिकॉज बिफोर एंटरिंग योर ए लेवल्स, you thought electron is a particle, light is a wave. But when you studied wave particle duality and quantum physics, you came to know, no, light is a wave. I know, because light can reflect, refract, diffract, superpose, interfere. But light was also proved as a particle when we talked about photoelectric effect and photons. Electrons, you always thought they are only particles, but then you came to know that electron can also produce diffraction patterns through a CRO. And yes, diffraction is a property of waves, so electrons can also have a behavior like waves as well. They used to also pass through a beam through horizontal and vertical planes, and then they used to produce the same diffraction pattern as well. These electron beams fired at crystal will always produce scattering experiment that can tell us about the structure of the crystal as well. And this was also proven by Davison and Germer, who were the students of Rutherford as well. This was different to the patterns found by alpha particle scattering experiment. These two again provided another experimental evidence to prove the theory, That was proven earlier by De Broglie as well. De Broglie wavelength जो इलेक्ट्रॉन डायफ्रैक्शन के ऊपर जिसने काम किया था, and light could also behave as a wave sometimes and also as a particle. The wave particle duality that you studied in quantum physics. He hypothesized that this might also be the case for things which were traditionally thought to be particles. De Broglie had proposed that the wavelength of the particle could be calculated from this momentum, and this is the same formula that you remember from your AS as well. Got it?
जी
And that is why Louis de Broglie was awarded 1929 with Nobel Prize for Physics for proving that electrons can also behave as a wave. This is also a very similar kind of a question. You can look at it as well. Uh, the idea of electrons acting as a wave has enabled scientists to study the structure of crystals now as well. The same way they do in X-ray crystallography, and when waves pass through a gap which is about the same size as their wavelength, they are diffracted. In other words, they spread out. And the degree of diffraction spreading depends on the ratio of the size of the gap to the wavelength of that wave as well. हम अब उस टेक्निक से हम क्रिस्टल्स के बारे में पता कर सकते हैं, हम बीम्स एंड लेज़र पैटर्न यूज़ करते हैं. वी टॉक अबाउट द क्रिस्टल एज वेल, क्रिस्टल की क्वालिटी, हाउ क्लोज आर द एटम्स पैक्ड इनटू द क्रिस्टल, व्हाट आर द डिफरेंट स्पेसेस between the atoms that have to be calculated. And both electron diffraction and alpha particle scattering show the idea that we can study the structure of matter by probing it with beams of high energy particles, which can be electron as well. You need high energies to investigate structure of nucleons as well, and accelerating. जितना आप उनको accelerate करोगे, the higher the energies, the higher the kinetic energies and velocities they will have, and that is why this is how Thomson tried discovering इलेक्ट्रॉन फाइनली इन 1897 एज वेल. किसी भी चीज को हाई एक्सेलरेशन पे, हाई वेलोसिटी पे मूव करवाओगे, दे विल ऑब्वियसली हैव अ हायर एनर्जी एज वेल. गॉट इट?
जी
एंड दैट इज द एंड ऑफ योर 7A.